Hello, good afternoon. Good afternoon. Oh, what happened? Your screen share is closed. Do you still have class? Good afternoon. Can you hear me?
Good afternoon, teacher.
You're sleepy.
Good afternoon, teacher.
Good afternoon. Let's wait for the others, okay? Turn on your cameras, please. Turn on your cameras. Turn on your cameras. I want to see your face. Turn on your cameras. How are you guys?
I'm very well, thank you. How about you?
I'm great. Oh, iPad, you're in the hospital. Who's sick? Who's sick? iPad, iPad. iPad, who's iPad? What's his name? Who's iPad? iPad, this one. Because he's using the name iPad. What's his name?
Sukatเหรอ?
Sukat.
What, teacher?
Who's sick, mommy? Mommy is sick?
Yes, teacher.
Tell mommy to get well soon, okay? Turn on your cameras, please. Hi, Prao. Is that delicious?
เที่ยวถามว่าแม่ปวดใช่ไหม
Yes. Turn on your cameras before we start. Let's wait for the others. Okay, so we are 30 now. So first, get your science book and open it on page. Page 27. Class book, page 27. Okay, I will share my screen. Can you see my screen now? Can you see it? Good. Please answer me if you can see it. Can you see my screen?
Yes.
Okay. So, separation techniques. Can you remember this? Separation techniques? Yes or no? No?
Yes.
No. Okay. So, separation techniques, how to separate mixtures? So, we have to choose a suitable separation method. We need to consider the properties of substances in the mixture. Example, solid and solid mixture together, like sand and stones. So you put them together, sand and stones. How do you separate them? How will you separate them? Okay. Another example, like the stone and water. How will you separate the stone and water? Separate, okay? To divide them together. So, like this. So, what is a mixture first? A substance made by mixing other substances together. Okay, it can be physically mixed or chemically mixed. So, like this, separation of solid to solid. Two solid materials. Example, this one, we use sieve to separate large flour particles from the fine flour particles. So, on top of, this one is the sieve, okay, remember? This one is the sieve. What's your question, Tirapov? Tirapov, can you help me? What's this to translate? Ah, wait. Tirapov sent. Wait. Tirapov, can you make it in group? Send it in everyone. I cannot understand.
What, teacher?
Tirapov. Now, Tirapov sent a message to me, but you cannot read it. And I cannot understand also because it's written in Thai. So I'm asking him to send in the group so that you can translate it for me. Tirapov, send your message in the group. Okay. So here, this one is the sieve. We put on the floor on top of the sieve, and then after that, we have to shake a little bit only, okay? And then after that, the fine particles or the tiny particles will go down like this. And then the solid particles or the large particles of flour will go or will stay on top or on the sieve. Understand?
Yes.
Next. So like this one, sifting gravel separates it into different sizes. Like this, we put the sand here and then we will separate the gravel. The gravel are the large particles or the large stones. Not very large, but big stones. And then the sand will go at the bottom like this. Okay? So we separate them. Two solid materials, the sand and the stones, or sand and the gravel. And then after that, in the junkyard, electromagnets are used to pick up scrap metals for recycling. So in junkyard, they use big magnets, not just small magnets, okay? Big magnets to separate or to get metals from non-metal. Okay? You know iron. Wait, who sent this? Tirapov page 29. 29. Okay, so in the junkyard, they use this one, the big magnet here, to get all the metal or to separate metal and non-metal materials. Example of non-metal materials, the cloth, the alloy, the aluminum, the wood, plastic, to separate them. So here, they get all the metals and then we'll put it together with the other metals like this. So electromagnets are controlled. Okay, it has the switch. Example, I will turn into magnet and then after that, I will off the magnet. Okay, it can on the magnet, turned on the magnet, and then turned off the magnet. So magnetic separation is used to extract metals from ores. Metal ores are ground into powder. The powdered ore is placed onto a belt which carries past magnetic rollers. So here, this is the feeder. Where will you put the sand or metal ores? If you say metal ores, like big stone, you cut it like a little bit, tiny bit, okay? You cannot cut it using the knife, but you cut it using the machine, okay? So they will grind it, and then turn into tiny particles, and then they will put in the feeder. So from the feeder, it will go to the magnetic roller. So the magnetic roller will get all the metal or all the magnetic materials. And then after that, the non-magnetic materials like the sand, the stone will go here. And the metal will go here in the magnetic. Example of magnetic material like iron, cobalt, nickel, iron, cobalt, nickel. Those are the magnetic materials. Understand? Do you understand this?
Yes.
So we finish this. So separating insoluble solids from a liquid. So we can separate insoluble solids from a liquid by pouring out the water. So this one, we have to pour the water out of the pot so we can get the rice. All right? That is how we separate insoluble solids from a liquid. Next, or we can use a filtration to separate small insoluble solids from a liquid or gas. So this one is like a muddy water. Muddy water, we have the filter here, the funnel, and then we have the stand. So we put the funnel here, we put the filter paper inside, and then we pour the water here. When we pour the water, the clear water or the water only will go at the bottom, will go here. And then the mud, the sand, the soil will stay here. Understand? Just like this. So the glass, this is the funnel. This is the filter paper, the color white. And then when you put the water, this one, the blue is the water, and then this is the residue or the mud or the soil. Okay? So when the mixture is passed through a filter paper, the solids are trapped by the filter paper while liquid flows through. So the liquid will go through here. Okay? So sewage treatment plants use filters to remove harmful substances in wastewater before the water is released into the river. Before we release the water, we have to clean it first. We have to remove the harmful substances. What are those? Poison gas, right? Poisonous gas, anything that is about gas, we have to remove from the water because the water, if it has the poison, the fish or the fishes will die. Get it? Get it? Okay. So we use surgical masks as filters, keeping dust particles out while letting air to pass through it. So the dust particles will be trapped here. Okay? So that we cannot inhale the dust, but the air can still go inside. Understand?
Yes.
So when brewing coffee, hot water is passed through coffee powder and a filter. The filter traps the coffee powder while allowing the coffee solution to pass through it. So when we put this one is the funnel, we have the filter paper, and then here, when we put the water, the mixture of coffee and the water will be here. And then the solid particle of the coffee or the large particles of the coffee will stay here. Cannot go here. So when you drink coffee, no large particles, only the liquid. Okay, no solid anymore. What's the answer here again? Which of the following mixtures can be separated by using a filter? Mixture of water and tea leaves, mixture of water and sugar, mixture of water and oil, mixture of dust particles and oxygen gas. Which mixtures can be separated? What's the answer?
A and B, A and B.
A and B.
B.
Okay. Next, this one. Oh, A and B, huh?
Oh,
What are
A and B, A and B.
A and D, mixture of dust particles and oxygen gas. So which of the following mixtures can be separated by evaporation? Mixture of rocks and soil, mixture of water, sea and salt, mixture of sand and iodine crystals, mixture of water-soluble, copper, sulfate, and water. What's the answer?
A mixture of water and sea salt.
Okay.
And a mixture of sand with iodine crystal.
Okay. What's your question, Ananchai? Ananchai? What's your question? Ananchai? Question. Tell me.
Page.
Page 38. 38. 38 of your class book. 38. 38. 38. Can you see it? Can you see it? Yes or no? 38. Sam Sipet. Class book, not workbook. Class book, class book, class book, not workbook, ha? Not workbook, class book. Can you see it? It's okay if you cannot see. Let's go. So water treatment plant. So I've shown you this, right? So I will let you watch the video again to know about the water treatment. How do the water treatment help the water cleaned? Okay.
Access to fresh water is one of the largest drivers of creating a modern society. But what allows everyone access to seemingly endless supplies of potable water? It depends on where you live, but chances are behind your tap, there's a municipal water treatment plant. There are two main types of water treatment plants, drinking water or wastewater plants.
Can you hear? Yes or no? Can you hear the video?
Access.
Yes.
The question
Yes.
remains, how exactly does one treatment plant take dirty river water or well water and turn it into water that is safe to drink? It involves a lot of processing using chemicals, filters, and removing all of the toxins and hazards from a given source. The entire process starts with something called coagulation and flocculation. All drinking water has to come from somewhere, usually being freshwater lakes, rivers, wells, or streams. In these water sources, there's going to be some amount of sediment as well as organic materials in the water. These particles of sand, bacteria, dirt, wood, etc., they all have to be removed before the water can be sent out to city residents. To do this, chemicals called coagulants are added to the water. These chemicals, such as aluminum sulfate or ferric chloride, work to help the particles in the water congeal together. Essentially, these chemicals have the opposite charges of suspended solids, like clays or silts. When combined, the charges of the particles are neutralized, allowing for them to stick together. Coagulants are often added to the water right at the inlet of a drinking water plant, where the water then goes into mixing basins called flocculation basins. In these basins, the solution of water and coagulant will slowly be mixed together to form what are called floc particles. After mixing for a set amount of time determined by water quality in the flocculation basins, the water is moved to sedimentation basins. It's in these holding tanks where the water sits for the floc particles to begin settling out at a faster and faster rate, which is the intended goal of this process. By simply adding and mixing these chemicals into the water and letting that water sit, a large portion of the sediment will settle out to the bottom as sludge, which can be taken away to a landfill or holding facility. The floc particles are ultimately removed from the bottom of basins, and the clean water, being the cleanest at the top due to the settling particles, flows over weirs to the next stage in the process. In some plants, engineers actually use dissolved air flotation tanks in place of sedimentation basins. In these cases, air is pumped into the bottom of the tanks, creating a cascade of tiny bubbles. As these bubbles float to the surface, they take floc particles with them, forming a film of floc on the surface of the tanks. Then a sweeper arm pushes the floc into a collection basin where it's taken to a handling facility. In dissolved air flotation tanks, the clean water is taken from the bottom, where the least amount of floc is. When it comes to designing wastewater treatment plants,
Papa Win, don't
engineers will
play.
vary
You listen.
techniques based on the water source and how they want their final water to taste.
Papa Win, Papa Warin,
What, teacher?
you listen, not to play. You can play later, okay? You have to listen first.
Feel or otherwise be treated. The only regulation is the quality of water being pumped to the city, and in most cases, it doesn't matter how plants get the water to that point, which allows civil engineers a lot of creative freedom in the process. After the majority of solids are removed from the water during coagulation and flocculation, followed by sedimentation, the water flows over weirs to the next step, filtration. The water at this point will start looking clear, but there will still be bacteria and very small suspended solids in the mix. The filtration process will seek to remove the remainder of the suspended solids and bacteria to further bring the water up to snuff. Nearly every potable water treatment plant will use a sand filter for this process. Even in plants where engineers may not think it's needed, often sand filters will be added simply for extra measures to ensure clean water at the end. Sand filters are exactly what they sound like, a basin of fine to coarse sand that filters water. It would theoretically be possible to treat drinking water with only sand filters, but that would result in frequently clogged sand filters, resulting in lower efficiency and more cleaning time. These sand filters can be set up in essentially two different ways. Either the water flows from the bottom and exits the top, or the water flows from the top and exits the bottom. Each layout presents its own set of unique problems, but the most common technique is actually for the water to flow from the bottom to the top. Sand filters aren't highly technical. Water just passes through them and particles get caught as they run out of space to flow through. However, while not highly technical, sand filters are highly efficient. Water flowing out of sand filters will need to have a clarity of around less than 0.3 NEPHELOMETRIC turbidity units, or NTU. Try saying that 3 times fast. Or whatever local code is used for water clarity. This measurement is essentially just a way to determine the number of particles still remaining in the water, or turbidity. Many treatment plants will also pass water through activated carbon basins, which you can essentially think of as giant Brita filter tanks. Activated carbon particles have hundreds of tiny pores on them that help remove the tiniest of sediment and bacteria. This process isn't wholly necessary, but it helps improve taste and odor, often a desired trait for city residents. At this point, the water should be mostly crystal clear, but there still remains some residual bacteria. That leads us to the next step, disinfection. There are three main ways of disinfection in the water treatment process, which can be used individually or in combination with one another, depending upon design. First, chlorine or chloramine treatment. There's ozone treatment, and finally, ultraviolet radiation treatment. In the US, the main method of disinfection is by adding chloramines or chlorine-based compounds. These compounds, such as chlorine dioxide or monochloramine, work to kill microorganisms. One downside to this process, though, is that these chemicals can react with other organic material in the water to create disinfection byproducts. These disinfection byproducts are harmful to human health and have to be prevented or mitigated. This extraneous reaction with other organic material is also why chlorine disinfection must come at the end of the treatment process. If added at the beginning, an abundance of disinfection byproducts would be created, causing a plethora of issues for the engineers and plant operators. Even with all of this, chlorine is used mainly because of how it kills pathogens. It not only kills any pathogens in the water at the plant, but residual chlorine levels also remain in the tap water, killing any contaminants that might get introduced after leaving the plant. Most cities or states will have maximum or minimum chlorine levels in the treated water in order to keep both the water treated and city residents safe. The other most common method of treatment is ultraviolet radiation. In this process, UV light is shined through the water, which scrambles any bacteria's DNA. This doesn't kill the bacteria, but it makes it impossible for them to reproduce, thus making them harmless. The main downside to this disinfection process is that it isn't residual like the chlorine, meaning that any bacteria introduced to the water after this process can't be treated. Finally, we're left with ozone treatment. This process involves adding ozone, O3, to the water, called ozonation. The ozone kills the bacteria in the water as well as improving the taste and odor. In most cases, this treatment process also requires that a chemical be used to remove any ozone at the end, such as sodium bisulfate, as not to cause any harmful effects to the city's population or anyone who might drink the water. After the water is treated in any one of these three disinfection processes, it's ready to be pumped into a city's pipe network for delivery to your tap. The water flowing out of a plant is tested for various levels of chemicals, particles, and other qualities all outlined in a plant's permit. This permit, set by the governing agency, regulates water quality and holds the treatment plant accountable in the treatment process. At this point, all the water is fit for human consumption per the permit, and the treatment plant is tasked with keeping it flowing through the pipes in your city. Constant pressures of 40 psi must be kept at the outlets of the water in the system so that in areas of high elevation in the pipe network, the water retains residual pressure. 1 foot in water elevation is directly correlated to an increase or
Okay,
decrease of.
so let's go to the next one. This one.
The world around us is filled with naturally occurring mixtures. Quite often, we might want to separate these mixtures into their components so that we can collect useful or precious chemicals. In our earlier video, Pure Substances and Mixtures, we defined a mixture as 2 or more substances that have been physically and not chemically combined. Mixtures may contain combinations of gases, liquids, and solids that can be separated through physical means. In other words, the separation of a mixture involves a physical change. A physical change is a change in the physical properties of a substance that does not involve a change in its chemical composition. This means that a physical change does not involve chemical bonds being formed or broken. Examples include changing between the physical states of solid, liquid, and gas, dissolving into or precipitating out of solution, and physically separating the components of mixtures. We need to consider the physical properties of a mixture when selecting separation techniques. Physical properties include particle size, density, melting and boiling points, solubility, magnetism, and electrostatic attraction. In a mixture, pure substances retain their distinct physical properties, and any differences in these physical properties can be used to separate mixtures. In this lesson, we will focus on separation techniques that rely on differences in particle size and density. Sometimes, the major difference between two or more components in a mixture is particle size. As mentioned in our lesson on pure substances and mixtures, sieving is a separation technique where particles are separated by size. Substances with particles that are smaller than the holes in the sieve will pass through, while substances with larger particles will collect in the sieve. Remember our earlier video, Pure Substances and Mixtures? Blackbeard the pirate wanted to separate a heterogeneous mixture of gold coins and sand. If you recall, a heterogeneous mixture is a mixture that has variable composition and properties. In comparison, a homogeneous mixture is a mixture that has uniform composition and properties. To separate the gold coins from the sand, Blackbeard used a sieve that had holes smaller than the gold coins, but larger than the sand particles. That way, the gold coins collected in the sieve, while the sand fell to the ground. In some mixtures, the key difference between two or more pure substances is their density. Density is the mass of a substance per unit volume. We usually measure density in kilograms per cubic meter or in grams per cubic centimeter. For example, water has a density of approximately 1 gram per cubic centimeter, while iron has a density of 7.8 grams per cubic centimeter. But beware, the mass or weight of a substance is not the same as its density. Density is the mass of a substance divided by its volume. If we consider a 1 kilogram chemistry textbook and 1 kilogram of feathers, they both have the same mass, 1 kilogram. But if you throw both of these into the ocean after your final exams, the chemistry textbook will sink while the feathers will float. This is because the 1 kilogram of feathers take up a much larger volume, so they have a lower density. Several separation techniques rely on differences in density, including sedimentation, decantation, centrifugation, and separation funnels. Sedimentation is a separation technique where insoluble particles suspended in mixtures are allowed to settle out from liquids or gases, often when the liquid or gas is stationary. In other words, if a solid particle cannot dissolve and is more dense than the surrounding mixture, then it will fall to the bottom. Sedimentation is often used to separate insoluble solids from mixtures containing insoluble solids and a liquid or gas. Liquid and gases can be referred to as fluids. When insoluble solids are separated from liquids, sedimentation is usually followed by decantation. Decantation involves pouring off a liquid from above insoluble particles that have settled at the bottom of a mixture. In other words, we can carefully pour out the liquid so that the more dense and insoluble solid remains at the bottom of the container. Let's see an application of this. Remember when Blackbeard accidentally tipped his boot full of sand into the last barrel of clean water? This resulted in a heterogeneous mixture of sand and water, which isn't very pleasant to drink. We know that sand has a higher density than water because sand sinks in water. Therefore, to separate clean water from sand, Blackbeard could use sedimentation followed by decantation. He could leave the mixture of sand and water to sit for a while, allowing the insoluble sand particles to settle out from the liquid water. Then he could carefully pour off the clean water from above the settled sand. Let's pause for a moment to look at the term miscibility. Miscibility refers to the ability of a liquid solute to dissolve in a liquid solvent. If two liquids are completely miscible, then we can mix them in any proportion to form a homogeneous mixture. For example, ethanol and water are miscible because we can make solutions using any concentrations of ethanol and water. If two substances are immiscible, then they cannot dissolve in each other, regardless of the proportions in which we mix them. Instead, they remain in two distinct layers, forming a heterogeneous mixture. For example, oil and water do not mix, whether we add a bit of water to oil or a bit of oil to water.
Okay, so if you look at this picture, so ethanol and water can be mixed because they have both the same substance. Okay, they have like same water and same color. While here in immiscible, oil and water, which is water is more denser or more heavier than the oil. Do you understand? Always remember that oil floats on any kind of water. Okay? Oil floats on any kind of water. If you put, example, you have the water, you put oil, the water will float only. But if you put, what's that? Soap. Example, you can do this at home. Okay? You put water, you put the soap, the liquid soap. Oh. Tanpi cha, what are you doing? Tanpi cha?
ใครเขียนกระดานเล่นคะ
You can
ค
play
นที่
like
เขียน
here.
ไปเขียนอ่ะ
Okay.
คนที่เขียน
So this
กระดาน
one
เล่น
is,
ชื่อมัน
this
ขึ้น
one
นะ
is,
คะ
okay, okay, you speak.
ไม่รู้ว่าพ่อใครมาเขียนไม่รู้อะ
Okay, so you can do this at home. Example, you put water and then you put oil, a little bit of oil only. So they will not mix, right? So the oil will goes up and the water will goes down. But if you put another liquid, the mixture will be mixed. You understand? The substances will be mixed. Example, the oil, the water, and then the soap, the liquid soap. If you mix them, they will be mixed. Understand? So if you put together those three substances, it will turn into a new substance. Okay? But I don't know what do you call that kind of substance. But the oil will be dissolved. Understand? The oil, the water will be dissolved if you put the soap. But if it doesn't have the soap, like oil and water only, even if you mix them together, you stir it together, they will not be mixed. Okay. So next, here. So fill in the blanks with the words provided in the box below. This is in your class book, page 42. Class book, page 42. Class book. Class book, page 42. Okay? So blank is suitable method to separate table salt dissolved in water. What is that? How will you separate?
Evaporation.
Very good. That is evaporation. Okay. If I see you writing on the screen next time, I will minus your score. Okay? If I see you again writing on the screen, like, what's her name again? Wait, let me see.
ถ้า
What's
ที
her
เชอร์
name?
เห็นใครเขียนกระดานเล่นอีกนะคะทีเชอร์จะทำการหักคะแนน
What's his name? Tanpicha? I think Tanpicha. I saw her writing on the screen. So next time, if I see you again, I will minus your score. Okay? Next, we can use blank to remove fine particles in dirty water. What is that? Example, clean water, dirty water with sand. What do we need to use to make it separated?
Filtration.
Very good. Filtration. Surgical mask act as a blank to keep out dust particles.
Filter.
Yes, of course, filter. Number 4, blank can be used to separate a mixture that contains a solid substance that turn directly into gas when heated.
Sublimation.
Sublimation. Lastly, we can use blank to separate a mixture of silver and iron fillings. The
Magnet.
magnet, of course. Got it? Finish?
Yes.
Everyone finish?
Yes.
Okay, so if you are finished, get your workbook. Workbook, page 12. Workbook, page 12 to 13. Okay. Page 12 to 13. Workbook, page 12 to 13. Finish? Are you finished here? Can we go now to the next one? Okay, so no one's answering. So this one, separation techniques. So you are given a mixture of sand, iron nails, and plastic beads. The flow chart below describes how the mixture can be separated. Fill in the blanks to complete the flow chart. So this is the mixture of sand, iron, nails, and plastic. So what separation method you need to do?
Sifting.
Sifting, very good. So you have to use sifting. Oh. Okay. So mixture here. What are the mixture here? You will remove what? The
Iron nails.
iron nails and
Iron nail and stick.
the plastic Kids. How about here?
Sand.
The sand. Okay. Next. Iron nails and plastic beads. What is the separation method you need to use?
Use magnet.
Magnet or the magnetic. Now, what will happen to them? This one will be iron
Iron and nails.
nails. And the other one is
Plastic.
plastic beads. Oh. Finish? Finish? No. Are you finished?
Yes, teacher. Finish.
Who's not finished? Who's not finished? Turn on your cameras. Where are your faces here? I told you to turn on your cameras. Where are the other students? Turn on your cameras. I see 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 face only. 6 out 10. 10 faces only. How about the others? Turn on your cameras. Okay, next. I will clear this. Amikigaw, what's that? Can you help me to translate it? What did she say? Her camera is not working?
Yes, he told that.
Okay. So next. So here, tea lives in a cup of coffee. So how can we separate them?
Filtration.
Okay, so that is the filtration. Nickel coins and wood chips.
Using magnet.
Using magnets. Iron fillings and sand.
Using magnet.
Using magnet. Fine dirt particles mixed in water. Fine dirt particles mixed in water. We use the precipitation. And then lastly, fine flour and plastic beads, we use sifting. Okay. Are you all finished? Turn on your cameras. Next time, if you don't turn on your camera, I will deduct or I will minus your points again. Do you want it? Do you want to get 0 because you don't listen to teacher? Turn on your cameras. Wasu, I like your ceiling. Turn on your cameras, please. How about the others? I can see 12 only. 12 faces only. Turn on your cameras.
Sure, some of them can't open the camera. I turn on the camera.
Turn on, it's all right. Okay, everyone finish?
Yes.
Yes.
Okay. So I have special reminder to you. On Thursday, I am not be able to teach you. Okay? I am not be able to teach you. I will not teach you on Thursday. But Teacher April will teach you. Do you know Teacher April?
Oh.
Yeah, teacher.
Okay, so Teacher April will teach you because I have a test in my school because I am studying again. Okay. So Teacher John is finished studying, but I want to learn more, so I study again. Do you understand?
Yes.
Okay. So I will be absent for 1 day only. So Teacher April will teach you and she will give you the word wall. Okay? So the topic in the word wall is all about the separation techniques only. You have to read the separation techniques so that in the test, you can answer it. Understand? No need for you to rush answering. When you are answering, you can read your books, you can open your books while answering so that you can answer it correctly. Don't do like click, 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 click only. Understand? Read, always read, think, and answer. Always put think. Understand? Read, think, answer. But if you do read and answer only, it's not good. You will get 0. Understand? Are we clear? Everyone, answer me. You can say yes, you can say no. Say yes if we are clear, if you understand, and say no if you don't understand.
Yes.
Yes. Yes.
Okay.
Yes.
We will see each other again on Tuesday. We will see next week again. All right? All right? Yes or no? Why are
Yes.
you not answering? Okay.
Again, teacher, I have noise pollution.
Huh?
Again, teacher.
We will see each other again on Tuesday. Thursday, Teacher April will teach you. Okay? Teacher John, I have test. Okay? I have test on Thursday, so I'm not be able to teach you. So Teacher April will cover my class. So don't go. Show me your faces and then let's take a picture. Smile. Show me your big smile. Big smile. Show me your teeth. Teeth, not feet. Okay, teeth. 1, 2, 3. Okay. Goodbye and see you. Stay safe.
Thank you, teacher. See you again next time. Bye bye. Bye bye.
Bye.
นะจ๊ะ
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 นะจ๊ะพ่อผมสิ
โอ้ยเฮ้ยอย่าพูดคำหยาบไม่ดี
ไกด์พวกคำหยาบ
ไม่ดีไม่ดีอย่าพูดคำหยาบ
มันจะมาไขสื่อ